Hello everyone, welcome back to my channel, the IITian Coder. This is a video editorial of the problem Replace for X of October Long Challenge 2020 Revision 1. So I had already posted a video on the hints and question explanation. Please do check it out. So you are given an array of n integers a1 to an, and there are 3 more integers x, p and k. So an operation on the array is defined to be you replace the kth smallest integer in the array with any integer you want, and you need to output the minimum number of operations you must perform on the array to make the pth smallest element of the array equal to x. If it is impossible to do so, just output -1. So this question was quite straightforward, and you just need to think of the 3 particular cases. So the constraints are that the n is 4 into 10 raised to 5. That means you can use an n log n solution easily. So let's see how to do this. So suppose we are given an array of integers a1, a2, a3, a4 and till an. Let us first sort the given array. So this sort them. Okay, so after you sort them, then what we can do is just like, let us say we get this equation b1, b2, b3, b3, b4, b5, so on till bn. So now there are majorly only 3 cases in which k is less than p, k is equal to p and k is greater than p. Okay, so let us first take the case k is less than p. That means let us say k is b3, this is k, and this is p, which is b5. So what we do is we need to make we are given a value x, so we need to make this value b3 equal to x. So now there are majorly 3 cases. Either b3 is equal to x, then we say the answer is 0 operations. Otherwise, if b3 is less, otherwise there are 2 cases. In this there are 2 cases. Okay, I don't have space now. b3 is less than x or b3 is greater than x. So these are the major 2 cases that we have. So let's suppose b3 is less than x. Okay, that means that I will take an example. Suppose b1 is 1, b2 is 2, b3 is 3, let's suppose, and x value is 4, and we have b4 equals 5, 6, 7, anything. You can take this numbers anything. Okay, so I need to make this value as 4. Okay, and I can change only this value. I cannot change anything. So what is the simplest solution that we get in mind? That b3 is less than x, so I can make this value 4, and sorry, b3 is less than x. Okay, so I need to make this 4. So what can I do is basically I can change this value to anything I want, and then the array will be resorted, and then I can change this value. But as you can see that there are 3 numbers 1, 2, 3 which are less than 4. So it will be impossible for me to make the third number equal to 4, because let's suppose I make x equal to 4, it will be the fourth number. Let's say I make this 6 greater than 4, then it will be just the changing of these numbers which have no use on us. And let us say I suppose make this less than 4, then I will get basically 1, 2 and some number here like this number, but I can never get 4 here. So I hope you got this point, that I can never get 4 here if b3 is less than x. So if b3 is equal to x, then we terminate the program, like we output 0 because it's already there. And if b3 is greater, this is -1 case, and if b3 is greater than x, okay, let's suppose this value was also 5. So what do I do is I find the position where 4 can be inserted. So 4 is to be inserted here. So I need to find the upper bound of 4. I need to find the upper bound of 4. Because each number I make 4 will be inserted at this position. If there are already 4's present before this, then they will be excluded. So I will found upper bound of 4, upper bound of x. Okay, so this will point to this value currently because this is the position where 4 will be inserted. This is the number just greater than 4. So this will point to here, and our answer will be upper bound of x minus the p. Oh, sorry, upper bound will always be less than p. You can see that because the pth value, which is b3, is greater than x. So either it will be pth value or less than pth value. So we can always do p minus upper bound plus 1 would be our answer. Now take the next case, k equals to p. This will be just a superposition. If b3 is equal to x, we output 0. If b3 is less than x, then we use this case. Here there will be two cases, b3, 4, 5. Here b5 is greater than x or b5 is less than x. By symmetry, you can see this would be -1. You can prove that also easily. And this here, if it was b4 less than x, b4 greater than x. So in b4 less than x, you can use this case similar to this, and in b4 greater than x, you can use this case. So I guess I have explained all cases. I will just explain it to you this one. So this will be lower bound of x, lower bound of x minus p. I guess there will not be a +1. I will take a look at my code and show you that. So let us take an example. Let's say the sequence 1, 5, 9, 17, anything, 23, 25. Okay, so let's take, we need to take k greater than p. Okay, so let's take k as this is a k and this is a p. This is already sorted to make you easy. You can always sort the sequence. Okay, so this is p. Okay, now the case is if b5 is greater than x. So let's take x as x equal to what do you want, 27. Okay, so b5 is less than x. Yeah, sure. So what I can do is, first move will be make 9 equal to 27. So my array becomes 1, 5, 17, 23, 23, 25 and 27. Okay, so now 1, 5, 17, this is p, 23, 25, this is k. One more time I make this 27. So after making this 27, my array becomes 1, 5, 23, 25, 27 and another 27, and I'm done because this is equal to x. So I can do this. I need to do this operation how many times? Lower bound of 27 minus p times, right? So lower bound will point to this. So one operation is left. Lower bound will point to n. So two operations are left. So the answer will be 2. So let us look at the code. I hope you understood this explanation and the various cases that we had to consider. Now I will explain it to you in my code. So this is my code. What do? We first include the libraries and all. we take in the number of test cases, we take the values of n, x, p, k, and then we declare an array of n and a vector of p, like long int. This you can do either one of them. I did both just for the explanation part. Okay, like you can do both. I need to explain that, right? So use an iteration variable, and you can take the numbers in the array, or you can push them in the vector. Then you can sort the vector, or you can sort the array, whichever you want. Then just check if p is, take three cases. If p is less than k, else if p equal to k, else other things. Okay, like p is greater than k. Now in each case check if the pth value is equal to x, out 0, and if p is less than k and the pth value is less than x, then it's never possible to achieve that. I showed you, because it will just rearrange the array and change the numbers, but you can never achieve the value of x at that. If you still have a doubt, you can leave it in the comment section and I can explain again, because it was like quite easy question. Okay, so see out -1. Otherwise just find the upper bound of this, and then you can the answer will be p minus it minus v dot begin. So it minus v dot begin is that span of, basically, see, suppose I did upper bound. Where did I do upper bound? v3 greater than x. Yeah, here I did upper bound, right? So it was pointing to here. So it minus v dot begin will be 0, 1, 2. So it minus v dot begin is 2. So here I told upper bound of x plus 1. So v dot begin is actually 0. So the plus 1 is accommodated there. So this, and then in this case it is just, if there is only n equal to 1, then in one operation I can change it to anything. Otherwise, if pth value is greater than x, use this. Otherwise, if pth value is less than x, then use this one. Okay, so this is the third case. So p is greater than k in this, and the pth value is equal to x. So if the pth value is equal to x, then we print 0. If pth value is greater than x, I can show you that it is never possible, so we print -1. Otherwise, you just take the lower bound and print it minus v dot begin, that is the position, minus p plus 1. Okay, so I have explained everything this question wants, I guess. So if you have any doubts or any comments or any requests, you can leave them in the comment section. Please do like, share and subscribe. And the impossible part, I will explain it to you once again so you don't miss out on anything. So the impossible part is very easy. So it is there because, see, suppose we have a sequence a1, a2, of course it is sorted, okay, a3, a4. I will explain to you one part of the impossible part. You can figure out the next on your own. Okay, so I will explain it to you on the case when k is less than p and b3 is less than x. Okay, so k, let's take k equals 2 and p equals 4. So k less than p, this is k, this is p, and the value of x, which is a2, is less than x. Okay, so now I can change this pth value to 3. I have 3 options: make it equal to x, make it less than x, make it greater than x. Okay, so suppose I make it equal to x, where would it be inserted? a2 is already less than x, right? So it will be always inserted after a2 if I make it equal to x. So I have no use of making this equal to x, because I will end up rearranging only these numbers, changing these values and all, but I can never impact these two numbers by making it equal to x or greater than x, right? So the only case I have left is make this less than x. So if I make this less than x, what I will do is either I will insert it here, or if I make it less than even a2, then I will end up making it here. So what will I get? This array will be changed to a1, a2 prime, and so on, right? So this a2 prime will will end up being less than a2, and a2 is already less than x. So I can always decrease the value at k while k is less than p. I can never increase the value at k. So I hope you understood this point. So please do like, share and subscribe, and thank you for watching.